Hey everybody, so today we're going to be taking a look at simple networked communication between MAX patches running on different computers. We're going to need a couple of things in order to get this set up. First of all, you're going to need to have a particular version of Java installed on both computers, all the computers on the network that want to communicate with each other, and look in the comments to this video or on the Discord for links to download the correct version of Java for your computer in order to run the object that we're going to be looking at today. Also, you're going to need a fairly insecure Wi-Fi network that doesn't have a lot of firewalls and blocked ports and blocked services. So particularly if you're on a university campus, you're going to want to set up your own Wi-Fi network. Your home network might allow this sort of network communication, but the best thing to do is to set up an empty Wi-Fi network. Just take an old router that's not connected to the internet and turn off all of its security features. Open all the ports, turn off the firewall, allow all communication protocols, and then password protect it, because it's a very insecure Wi-Fi network now, to be used only for this real-time network communication between patches. And so any computers connected to the same network, any computers connected to the same Wi-Fi will be able to communicate with this object, mxj space net.maxhole. And the reason why you need Java installed to run this is this object is written in Java and it runs on a Java virtual machine on your computer. So it's an extension of Max that incorporates another language, the Java language, which is distinct from the JavaScript language, which also runs in Max. But this is Java, which is quite a low-level language, which is good for writing networking applications like this. Any message that goes into a Max hole comes out all instances of the Max hole. So this can be an integer, a floating point value, a symbol, a list, any data type sent into a Max hole comes out all Max holes, whether they're on the same computer or whether they're on a different computer. So here I've got this patch, which is simulating being on a different computer. Now, you don't need two computers in order to write patches that will communicate between two computers. You can actually write both patches on the same computer, as I'm doing here. These patches are both physically sitting on the same computer right now, but the goal is to be able to network between multiple computers. So I would close this computer to patch on this computer and open it up on a different computer, and it should function exactly the way you're going to see it functioning here. So now when I send hello, it comes out of the local Max hole. It also comes out of the remote Max hole, whether it's in another patcher on the same computer or whether it's in a patcher on a remote computer that's connected to the same network. And notice that my input value here didn't change. It's only what's coming out of the Max hole to set the contents of this message box. So now I can send 1, 2, 3, 4, 5 from computer 2, and that 1, 2, 3, 4, 5 will come out the local Max hole and the remote Max hole. So it's just a very simple tool for getting information moving between computers very easily. Now, of course, if the patches are on the same computer, it's easier to just use send and receive. And this will allow you to send and receive information on the same computer. But as soon as I move this patch to a different computer, my send and receive will stop working. Send and receive don't work over the network, whereas mxj net.maxhole does work over the network. Now immediately we can see a difference between mxj net.maxhole and send and receive. Essentially all Maxhole objects are both send and receive objects, and you can't name them. You can't be specific about where the data is being sent. But there's an easy way to solve that, which is to simply always transmit your data as a list. So I'll say comp1 hello, and it sends that out. And this can be comp2 hi there. So now we know where the message is coming from, simply by putting a different word in front of it. Comp1, computer 1, sent the word hello, and every MaxHole is reporting who sent it and what the message is. Comp2 sends the message hi there, and every MaxHole object is reporting the entire message, which is a list now, the source of the message and the contents of the message. So using the route object, we can remove our own messages from the stream. So now this is functioning like a send. Comp1 hello will be received here, but it won't be received locally because we've used the route object to look for any lists that begin with the word comp1, strip that comp1 symbol off, and send it out the left. And the right outlet gives us anything else. And we do the same thing here. The route is stripping out local messages and only giving us messages from a remote destination. So messages from comp1 will be received by comp2. Messages from comp2 will be received by comp1, etc. So a very simple application of this, just to test it out if you're on a network, is to create a little chat room in Max. You can use the text edit object. Go to info on the text edit object and enable the return enters text attribute, and then you can type in text and hit return and it will send it. And it puts the word text, it prepends the word text in front of the message. So we want to route that off. Route text will chop the word text off the front of that message. And then a new object we want to prepend, which simply means to put before. It's like the pack object. It puts a word before whatever comes in. So we'll route text and we'll prepend comp1. And then any message sent by computer 1 will have this comp1 prepended to it. We'll take a look at this in the message box again. When I send this message, this is computer 1, it strips off the word text and puts on the comp1 label. So now it says comp1, this is computer 1. And we can do exactly the same thing on our other computer. Prepend comp2. We can restore those message boxes so that we can see what is going on. And say, so comp1 said hello from comp1, and comp2 replies, hi there. Comp2 replied, hi there. And if we want to see this all, we can certainly just print what's coming out of the MXJ net.maxhole to see in the Max window the entire conversation of our chat room. So comp1 said good day, and comp2 says Good day to you too. So now, see, we've got a chat thread going here, and this can work on as many computers as are on the network. So all of your Max patches can be talking to each other. But of course, a chat room is not what we want to create. I just wanted to illustrate how easy it is to create something like a chat room using this simple networking tool. What we want to do is we want to send messages between Max patches so that multiple computers can be synchronized with each other. Multiple computers can know what the other computer is doing and can respond to each other and information from external sources. So what we're going to do here is we're going to look at the NMSVE. But any MIDI controller will work fine for this. So here we've got the MIDI input objects that we've looked at in previous tutorials. Here's my noise machine. I'll get my list of controllers, choose the noise machine, and check and see that it's working. And it is. It's sending notes, and it's sending the controller. Great. So using our same structure here, and again, you should keep all of this work, comment it, put it in a separate subpatcher, start a new patch if you want to. I'm going to delete it for the sake of keeping the screen clean. I can now pipe information from the NMSVE or from any device, from my keyboard, from my mouse, from a different MIDI controller, from video analysis, from sound analysis. I can pipe any information to all other computers on the network. So these standard transformations that we looked at in the previous tutorial. Pack with no arguments by default packs 2 integers. And you can see why this is once you start working with MIDI, because 2 integer lists are extremely common. And then we'll tag these, we'll prepend comp1 so we know where the information's coming from. And when we press the NMSVE, we can see on computer 2 this information is coming in. When I depress button number 1 on the NMSVE, that information is sent into the max hole and comes out the max hole here. And this transformation, we can put a message box here so we can see this on this side. I'm just subtracting 35 from the note number so that my top left button is button 1, and I'm saying when this value is greater than 0, report true, otherwise report false, which gives me button 6 down, button 6 up. And of course I can take this information now on my receiving computer, and I can say, okay, I want to route the information that's coming from computer 1 now, specifically. So I'm going to route comp 1. So now my second outlet here is looking for the information that's coming from computer 1, which in this case is the NMSVE data. And then I want to, when the button is depressed, play the sound, and when the button is released, stop the sound. So there's a couple ways to go about this. The way that you might intuit would be to unpack this information and use a G-gate so that when the button is pressed, it triggers the sound. And when any button is released, the sound is paused. And this will work. And if we want to test out that pause feature, we We can do it by looping the sounds. I'll show you a slightly more max way to handle this. Keep this, maybe put in a subpatcher, or just make a separate version of this. This version is valid. The somewhat more max-like version, and now that you're aware of $ arguments, would be $2, $1. This flips my list so that now my on-off status is the first value and which note is the second. And that allows us to pass this to a route. All my button downs will come out here, and all my button ups will come out there. Exactly the same thing, just slightly more grammatically max-like and a little bit easier to read. If we loop these, we can hear that the pause is working. So that's very useful. But now what if we have two types of information? Like we have our controller values and our note values. How do we differentiate them? Well, in the same way that we prepended comp1 to tag the message with the computer that it's coming from, we can also tag it with the kind of data it is. So why don't we say prepend note? And now this structure is no longer going to work, because what's coming out has an extra word in it. We've added the word note. So now we'll need another route to specifically select note messages. Route, note. If we just want to monitor the total list that we're sending, we can do that here before the max hole. Just to see what we're sending out. So now it's a long list. It's the source, the type of information, and then the information. So why are we adding this additional layer of complexity? Because we have another type of information we want to send. So here we might prepend cont, just short for controller. And remember, everything I'm putting in all caps are arbitrary names. They're just names I'm picking because they make sense to me. You will pick different things. That's absolutely fine. I'm prepending cont and also specifying this is coming from computer 1. And now my dial is tagged differently than my buttons. So on the receiving end, I could again route cont, and my controller values will come out here. So that's just a quick introduction to strategies for using MXJ net.maxhole to send information from one computer to another.